Above us, stretching silently across the night sky, lies a faint, glowing river of light. For thousands of years, it has been seen by human eyes, but never fully understood. This is the Milky Way, our home galaxy. From Earth, it appears as a hazy band, arching from horizon to horizon. This soft, milky glow is not a cloud, but the combined light of billions of distant stars, packed so densely that the human eye cannot distinguish them individually. What we are seeing is the inner structure of a vast cosmic system, viewed from within. The Milky Way is a barred spiral galaxy, a rotating disk of stars, gas, and dust, anchored by a dense central core. From this core extend sweeping spiral arms where new stars are born and entire solar systems take shape. Its scale is almost beyond comprehension. Stretching roughly 100,000 light-years across, it contains hundreds of billions of stars and likely just as many planets. Every star visible in the night sky belongs to this single galaxy, including our own sun. And yet, despite its immense size, what we see from Earth is only a thin slice, a narrow edge of a much larger cosmic structure. We are not observing the Milky Way from afar, we are inside it. And this glowing band in the sky is our first glimpse into the vast system that gave rise to everything we know. But how did this immense galaxy come into existence? To understand that, we must go back to the very beginning of structure in the universe.
Before the Milky Way, there was only darkness. After the Big Bang, the universe expanded rapidly, hot, dense, and nearly uniform, but not perfectly uniform. Tiny irregularities, minute fluctuations in density, were scattered throughout space. These imperfections would change everything. Over millions of years, gravity began to amplify these slight differences. Regions with just a little more matter pulled in even more, slowly building invisible scaffolds of dark matter across the cosmos. This was the birth of the cosmic web, vast filaments of matter stretching across the universe. Within these dense regions, gas began to collapse. Then, after hundreds of millions of years of darkness, the first light appeared. The first stars ignited. These were not like the stars we see today. They were massive, short-lived, and incredibly powerful, burning hot and dying young. Their light ended the cosmic dark ages, flooding the universe with radiation and forging the first heavy elements. Some of these early stars gathered into tightly bound groups, globular clusters, ancient, densely packed spheres containing hundreds of thousands of stars, many of which still exist today, orbiting the outer regions of our galaxy like relics of a forgotten era. These clusters are not just stars, they are fossils, remnants of the earliest stages of galaxy formation. Over time, more gas fell into these growing structures. Small proto-galaxies began to form, merge, and evolve. Among them, the earliest version of what would become the Milky Way, a galaxy not yet shaped, not yet structured, but already alive with stars. From these primordial seeds, something far greater was about to emerge. In the early universe, the Milky Way was not a galaxy. It was chaos. Vast clouds of gas drifted through space, cold, diffuse, and unstructured. But gravity was already at work, pulling this scattered matter inward, gathering it into a growing mass. Slowly, the collapse began. As more gas fell inward, something unexpected happened. It started to spin. Not because anything pushed it, but because of a fundamental rule of physics.
conservation of angular momentum. As the cloud contracted, its rotation sped up, just like a spinning skater pulling in their arms. Faster, tighter, more organized, the once shapeless cloud began to flatten. What started as a loose three-dimensional cloud transformed into a rotating disk, thin, wide, and dynamic. Gas settled into this plane, colliding, compressing, and cooling as it spiraled inward. This was the turning point. Chaos was becoming structure. Within this spinning disk, density waves formed, regions where gas piled up, triggering bursts of star formation. The earliest outlines of spiral arms began to emerge, not as fixed structures, but as patterns moving through the galaxy. The Milky Way was no longer just forming, it was organizing. From a turbulent beginning, a recognizable galaxy was taking shape, a rotating system governed by gravity, motion, and time. And within this newly formed disk, the next chapter would unfold, a story of growth, collisions, and transformation on a galactic scale. The Milky Way did not grow quietly. It grew by consuming. In its early history, our galaxy was surrounded by smaller, unstable galaxies, drifting too close to escape its gravity. When they approached, they weren't simply absorbed, they were torn apart. Stars were stretched into long, glowing streams. Gas was stripped away and pulled inward. Entire galaxies were dismantled, piece by piece. One of the most dramatic events was a collision with a massive ancient galaxy, often referred to as the Kraken. This was no minor encounter. It reshaped the young Milky Way, adding vast amounts of stars and altering its structure forever. But the process didn't stop there. Even today, the Milky Way continues to grow through accretion, pulling in gas from its surroundings and devouring smaller dwarf galaxies. These interactions leave behind faint trails of stars, stellar streams, ghostly signatures of past collisions that still wrap around our galaxy. Two of its most prominent companions, the large and small Magellanic Clouds, are caught in this gravitational dance. As they orbit the Milky Way, they leave behind a massive ribbon of gas known as the Magellanic Stream, stretching across the sky like a cosmic scar. These are not distant neighbors, they are future victims. Every merger, every stream, every fragment of captured matter has helped build the Milky Way into what it is today, a massive, evolving system shaped by billions of years of interaction. A galaxy forged not just by creation, but by collision. And as it continued to grow, its structure became more defined, more complex, and far more powerful. Over time, the Milky Way began to take on a recognizable form, not just a spinning disk, but a structured galaxy, with distinct regions, each playing a role in its evolution. At its core, a dense concentration of ancient stars gathered into what we now call the galactic bulge. This central region became crowded, chaotic, and gravitationally intense, a relic of the galaxy's earliest formation. Then something remarkable emerged from within it, a central bar, a vast, elongated structure of stars cutting through the heart of the galaxy, acting like a cosmic engine. This bar channels gas inward, fueling star formation and shaping the motion of the entire disk. Beyond the core, the galaxy's most iconic features began to appear, the spiral arms. But these are not solid structures. They are waves of density sweeping through the disk. As gas flows into these regions, it compresses, ignites, and gives birth to new stars. Bright blue and short-lived, these stars illuminate the arms, making them visible across the cosmos. Meanwhile, far beyond the disk, a different structure surrounds the galaxy, a vast spherical halo, sparse, ancient, and mysterious. Here, globular clusters orbit like distant satellites, dense spheres of some of the oldest stars in the universe, holding clues to the Milky Way's earliest past. And throughout all of this, stars and gas are not evenly spread. Young stars cluster in the spiral arms. Older stars dominate the bulge and halo. Gas and dust trace the disk, forming the raw material for future generations of stars. This is no random arrangement. It is a system shaped by gravity, motion, and billions of years of evolution. The Milky Way is no longer forming its structure. Its structure is now defining it. And at the center of it all lies something even more powerful.
At the very heart of the Milky Way lies something we cannot see, yet everything around it reveals its presence. Hidden behind thick clouds of gas and dust, in the direction of Sagittarius, is a region of extreme gravity, an invisible anchor holding the galaxy together. This is Sagittarius A star, a supermassive black hole containing over 4 million times the mass of our Sun. It did not appear suddenly. It grew, slowly, relentlessly, feeding on gas, stars, and possibly even entire star clusters during the galaxy's early, violent history. As the Milky Way formed and evolved, so did its core. And at that core, gravity reached its ultimate form. But Sagittarius A star is not just a passive object. It shapes its environment. Stars near the center orbit at incredible speeds, tracing tight, curved paths around something they cannot escape. Their motion is the proof, clear, precise, undeniable, that an immense mass lies hidden there. When matter falls toward the black hole, it doesn't disappear quietly. It heats up, accelerates, and emits powerful bursts of X-rays and gamma radiation before crossing the point of no return. Occasionally, sudden flares erupt, brief, intense flashes that echo across the galaxy. This region is not calm. It is dynamic, energetic, and unstable. Yet paradoxically, this chaotic center plays a role in maintaining the galaxy's structure. The gravitational influence of the central mass helps organize the motion of stars and gas on a galactic scale. The Milky Way is not just a collection of stars. It is a system anchored by something dark, powerful, and almost unimaginable. At its center, space itself is pushed to its limits. And beyond this core, another mystery silently shapes the galaxy, something we cannot see at all. If we could see the Milky Way as it truly is, most of it would still be invisible. Because the galaxy is not held together by stars alone, it is held together by something we cannot see: dark matter. Astronomers first realized something was wrong when they measured how stars move around the galaxy. According to gravity, stars farther from the center should orbit more slowly, but they don't. Instead, stars at the outer edges move just as fast as those near the core. This creates what's known as a flat rotation curve, a pattern that defies the visible mass of the galaxy. Something unseen is adding extra gravity, something massive and everywhere. To explain this, scientists proposed a vast invisible structure surrounding the Milky Way, a dark matter halo. This halo extends far beyond the visible disk, enveloping the galaxy in a massive, spherical cloud of unseen matter. It does not emit light, it does not interact with radiation, but it exerts gravity, and that changes everything. Dark matter acts as the framework of the galaxy,
Long before stars formed, this invisible mass created gravitational wells, regions where gas could collapse, giving birth to galaxies like the Milky Way. Even today, it continues to shape the galaxy's motion, stability, and growth. Without dark matter, the Milky Way as we know it could not exist. The stars would drift apart, the structure would collapse, the galaxy itself would unravel. So while we look up and see a river of light across the sky, what truly holds it together remains completely unseen. And within this hidden framework, the cycle of star formation continues, shaping the next generation of cosmic structures.
The Milky Way is not a finished structure. It is still creating. Across its vast disk, new stars are constantly being born, lighting up the galaxy in an ongoing cycle of creation. But this process is not random. It is concentrated in the galaxy's spiral arms. These arms are not solid structures. They are moving waves of density. As gas and dust drift through them, they are compressed, squeezed by gravity into dense regions where something extraordinary begins. Inside these regions lie giant molecular clouds, cold, massive reservoirs of gas, primarily hydrogen. Here, gravity takes over. The clouds fragment, collapse, and form dense cores. Within them, pressure and temperature rise until nuclear fusion ignites. A new star is born. Some of these stars are small and long-lived, like our Sun. Others are massive, brilliant, and short-lived, burning intensely and ending in powerful supernova explosions that scatter heavy elements back into space. This recycled material becomes the fuel for the next generation of stars, a continuous cycle, birth, death, and rebirth. But this process is not constant forever. Over billions of years, the Milky Way has been slowly using up its supply of cold gas. Star formation still continues, but at a declining rate. The galaxy is gradually transitioning from a highly active star-forming system to a quieter, more stable one. One day, the spiral arms may fade, the brilliant blue stars will disappear, and star formation will slow to a near halt. But for now, the Milky Way is still alive, still forming, still creating the building blocks of future solar systems. And within one of these regions, billions of years ago, something familiar began to take shape. Somewhere within this vast galaxy is us. Not at the center, not at the edge, but in a quiet, unremarkable region of the Milky Way, known as the Orion Arm, a small spur between larger spiral arms. This is where the Sun was born. About 27,000 light-years from the galactic center, far enough to avoid the intense radiation and gravitational chaos of the core, yet close enough to remain within the galaxy's active disk. It is a position of balance. But the Sun is not stationary. It is moving, carrying the entire solar system with it in a massive orbit around the center of the galaxy. Traveling at around 220 kilometers per second, it takes roughly 240 million years to complete a single orbit. One full journey around the Milky Way, a galactic year. Since its formation, the Sun has completed only about 20 of these orbits. And yet, during that time, something extraordinary happened. Life emerged. This is not a coincidence of location alone. The Sun resides within what astronomers call the galactic habitable zone, a region where conditions are just right, not too close to frequent supernova explosions, not too far where heavy elements are scarce, a region where stability allows complexity to develop, where planets can form, where life has a chance. In a galaxy of hundreds of billions of stars, our position is not special in appearance,
but it is precise in consequence. Because here, in this narrow band of space, the conditions aligned perfectly. And from this position, a small cloud of gas and dust would collapse, giving birth to something new. The Milky Way is not a relic of the past. It is alive, a vast, dynamic system, constantly changing, constantly evolving. Today, it exists as a barred spiral galaxy, a rotating disk of stars and gas anchored by a dense central bulge, threaded with spiral arms, and surrounded by an enormous, invisible halo of dark matter. But what truly defines it is its scale. The Milky Way contains hundreds of billions of stars. Around them, likely hundreds of billions of planets, worlds of every kind, from frozen wastelands to potential Earth-like environments. And between these stars lies a hidden population, dead stars, white dwarfs, the fading remnants of sun-like stars, neutron stars, ultra-dense cores left behind after violent supernovae, and stellar black holes, regions where gravity has completely collapsed matter into darkness. This is a galaxy not just of light, but of life cycles. Stars are born in glowing nebulae, they burn, evolve, and die. Their remnants seed the galaxy with heavier elements, fueling the next generation, a continuous transformation. Even now, the Milky Way is still growing. It pulls in gas from its surroundings. It disrupts and absorbs smaller galaxies. It reshapes itself through gravitational interactions, subtle shifts, and slow, persistent change. Nothing here is static. Everything is in motion. The Milky Way we see today is only a snapshot, one moment in a timeline spanning billions of years, a living galaxy, still writing its own story. And that story is far from over.
The Milky Way's story does not end in silence. It ends in collision. Far beyond our galaxy, a massive spiral, the Andromeda galaxy, is already on its way toward us. Invisible to the naked eye as a threat, but moving closer with every passing moment. In about 4 billion years, the two galaxies will meet, not as a sudden crash, but as a slow gravitational dance. As they approach, their shapes will begin to distort. Spiral arms will stretch and twist. Vast streams of stars will be pulled across space, forming glowing bridges between the two galaxies. Then, the first passage. They will swing through each other, tearing, reshaping, and scattering stars across millions of light years. But here's the paradox. Despite containing hundreds of billions of stars, almost none will collide directly. Space is simply too vast. Instead, gravity will do the work. Over billions of years, the two galaxies will merge, orbiting, distorting, and finally settling into a single new structure. The spiral forms will disappear. In their place, a giant elliptical galaxy will emerge, sometimes called Milkomeda. Star formation will gradually decline. The bright blue stars will fade. The galaxy will grow quieter, older, more stable. This is the long-term fate of the Milky Way. Not destruction, but transformation. A final stage in a cosmic life cycle that began billions of years ago. And by then, the night sky, if anything remains to observe it, will look completely different. Because galaxies, like everything in the universe, are not permanent. They evolve.
The Milky Way is not a static structure frozen in time. It is a system in motion. Stars orbit the galactic center at immense speeds. Gas flows through spiral arms, collapsing into new generations of stars. Ancient clusters drift through the halo, carrying memories of the galaxy's earliest days. Everything is moving.
everything is changing. Over billions of years, the Milky Way has grown from tiny fluctuations in the early universe into a vast, structured galaxy filled with stars, planets, and the raw ingredients for life. And even now, it continues to evolve. New stars are still being born, old ones are still dying, galaxies are still merging. This is not just a galaxy, it is a process, a continuous transformation unfolding across cosmic time. But within this immense system, something remarkable happened. In one quiet region of a spiral arm, inside a cold, dense cloud of gas and dust, gravity began to pull matter together. Not to form a galaxy, but something smaller, something closer, a star, and around it, a system of planets. In the next episode, we follow that moment, the birth of the cloud that would become our solar system.